You know the feeling, right? Your computer just freezes, an app crashes out of nowhere, or you get one of those bizarre error messages that makes absolutely no sense. It's so frustrating. It feels like your own machine is plotting against you. But what if I told you that you can become a kind of digital detective, able to crack even the weirdest computer cases? Let's dig in. And no, this isn't a joke. This is a real error message that Mark Russinovich, the guy who actually created the tools we're about to talk about, saw on his own screen. It's just the perfect example of how the problem you see is almost never the real problem. The system is telling you one thing, but the clues to the real culprit are buried way, way deeper. So, how do we get past these useless messages? How do we find out what's really going on under the hood? Well, you've got a mystery on your hands, and like any good mystery, it needs an investigator who's willing to follow the trail of clues. And that brings us right into our first section, computers' unexplained cases. To solve these, you really have to change your mindset. We're not just computer users anymore. We're detectives. This is the #1 rule. You have to stop trusting the symptoms. That application hang, that random error, that's just the start of the trail. The real clues, the good stuff, it's all hidden in what the system is actually doing. The files it's trying to open, the registry keys it's looking for, all the little conversations happening in the background. Our job is to go in and find them. Of course, every good detective needs their toolkit. And that's section 2, the Digital Detective's Toolkit. Luckily for us, we've got an amazing set of free tools from Sysinternals made by Mark Russinovich that let us peek behind the curtain and see exactly what's going on. First up is Process Explorer. Just think of this as answering the question, who? Who is at the crime scene? It's like a super-powered task manager that shows you every single process running, who started who, and exactly what resources they're eating up. It's our first step to spotting any suspicious characters. Next in the kit, we have Autoruns. This tool answers the how. How did our suspect even get to the crime scene? It's basically a full background check on your system, showing you literally everything that's set to start up automatically when you turn on your computer. This is where all sorts of misbehaving software and even malware loves to hide. And finally, the undisputed star of our show, Process Monitor. This tool is the what and the why. Seriously, it's like having continuous surveillance footage of your entire system. It logs every file access, every registry change, every network connection, all in real time. It gives you just incredibly detailed play-by-play of everything that happened right before things went wrong. Okay, now that we've got our tools, it's time for section 3, following the digital trail. Let's put this new toolkit to the test with our first real case. Now, this was a real widespread problem. People would open a specific email from PayPal and boom, Outlook would just lock up. Totally frozen for a full 30 seconds. Everyone was blaming Outlook, of course, but the real culprit was hiding in plain sight. So the detective work begins by capturing that freeze with Process Monitor. And when you look at the trace from Process Monitor, something just jumps off the page. You see the duration column, thousands of little operations taking just milliseconds. And then, bam, one single file operation takes over 30 seconds. That's it. That's our smoking gun. The entire half-minute freeze is caused by this one single event. So here's what was happening. Deep inside the email's code was a tracking image, but its address was written to look like a local file path. So Outlook tried to access it, thinking it was on a local server. But that server didn't exist, so it just sat there, waiting and waiting for the network request to time out. And the default timeout? 30 seconds. It wasn't an Outlook bug at all. It was just a badly formed link in an email. Case closed. All right, so that first case was pretty easy once we saw the data, but some mysteries are a lot tougher. That brings us to section 4, cracking the toughest cases. For these, especially when a problem is inconsistent, we need to compare the evidence. So get this one, another real head-scratcher. On the very same computer, if you looked at the properties for a new PowerPoint file, a .ppsx file, you'd see the Details tab. But if you looked at an older .pps file, that tab was just gone. A feature just vanished, but only for one specific file type. So what on earth is the difference? This is where you have to get clever. by running 2 process monitor traces, one while opening the properties of the working file and another for the failing one, and then comparing them side by side. The answer just becomes crystal clear. The investigator saw it right away. For the working file, the system looked in the registry and found the right handler it needed. But for the failing file, it looked for a similar registry key and found nothing. The key simply didn't exist. No key, no handler, no details tab. And the solution was just beautiful. So simple. The investigator just exported the working registry keys, opened the file in a text editor, did a find and replace to change PPS-X to PPS, and then imported it back into the registry. The missing keys were created, and poof, the Details tab instantly reappeared. It's just a perfect example of using data to find a precise surgical fix. So after seeing these cases, everything from freezes to features that just disappear, it's pretty clear there's a powerful method at work here. And that brings us to our final section, Section 5, the troubleshooter's golden rule. There is one single principle that ties all of this together. And here it is. This is it, the single most important takeaway, and it's Mark Russinovich's own mantra. No matter what the problem is, if something's slow, if there's an error, if something's crashing, your first move, your gut instinct, should be to capture what's happening with Process Monitor. The clues, they are almost always in the data. So here's your method. It's really that simple. Step 1, observe the problem. Step 2, form a quick hypothesis, a little theory. I bet it's a network issue. Step 3, use your tools, especially Process Monitor, to gather the hard data. And step 4, analyze those clues. That data will either prove or disprove your theory and lead you straight to the root cause. So now you have it. You've got the toolkit of a digital detective, and you've got the investigative mindset to match. The only question left is, what mysteries, what unexplained cases are lurking on your computer right now, just waiting to be cracked?